So on multimeters, what else should we know about multimeters from a layman's perspective here?
So there's a lot of cool things, like a lot of meters over here, right? So this is a very typical standard meter that you'll see a lot of places. This one and this one, just a basic fluke meter. And like I said, pay attention to all the stuff. This is one thing that gets a lot of people is you've got on here white symbols and yellow. Well, yellow only applies when you press the shift function, right? So it's like on your computer, you got to press the function button or whatever, or on your calculator, and then that puts you in the other mode. So if I'm right here on tone, which is beep, right? Continuity check, great, right? But it won't be in diode check until I push the button.
Yeah.
So there's a lot of those on there. A lot of people don't know it. Some meters also have blue options there. They have another button there, but it just depends on functionality. I'm pretty sure what I'm talking about is the 1577s. They have a blue button where you can also push it to change your range or something like that.
And that's the big thing as they get more complex, or at least that's been in my humble experience, is like, you only have so much real estate on the face of the meter, and so you offer a shift mode, and then they can offer a third dynamic that'll allow 3 modes of functionality, basically.
Yep. This is a FLIR multimeter. I love this little guy.
That one's sweet.
It's a pretty sweet little meter. This is actually one of their IR camera ones, so I can actually do IR inspection at the same time. But it's not real high quality inspection, but it's good enough to get you by a pickle if you're in it. But there's a lot of cool functions on here, like low Z and stuff like this. This is really good for, a lot of people don't know what low Z is. It's a low Z. Z stands for impedance.
Yep.
So it's low impedance input. So most of your multimeters are a high impedance input, like I was talking about with the voltmeter, right? You don't want to measure something with such a low resistance that you drop the voltage of the circuit, right? You want to use a high resistance input, so that way you don't affect what you're measuring. It's one of the rules of metering, right? And so, but the problem is when you're in like low voltage wiring, you might have a ghost voltage going on in your walls. And you're like, I can't find this thing, I don't know what the source is. It's usually induced voltages from another line. And so this low Z is really cool because this is a low impedance input now. So they lower the impedance, and therefore all your ghost voltages, which were actually not real, they're shorted out through the meter. And now you don't ever see them anymore. So you're like, no, I put it on low Z. I'm not seeing anything.
Can you kind of touch on that too? So, and we talk low impedance and ghost voltage. Can you kind of explain how ghost voltage can be introduced into residential wiring? Because I think that's a unique concept that people may not understand what you know what I mean?
Yeah, no, so if you have, say you have 2 parallel wires, right? You got one circuit that runs to the garage and one circuit that runs to the bathroom or whatever, right? Well, if you turn on one, and if for a while, and say throughout the kitchen wall, they run parallel with each other, right? So now if I turn on the switch on one, right, I'm going to flash a voltage across that circuit. That circuit now became live. Well, the other circuit since it's in such close proximity, it acts like a capacitor, and it sees some of that flash, right? And so if you take a multimeter over to it, you're like, whoa, what's going on here? I never turned this circuit on. But it's just it's a lot of people call it a ghost voltage is what they call it. And that's all it is just an induced voltage. That's the engineering concept of it. Right. The layman's term is a ghost voltage. Right. But the low
and it's mainly due to the fields it's really, a lot of people don't realize that there are invisible fields that come off of a power source, and that's kind of how you get the transient voltages or ghost voltages or whatever you may see.
Yeah, all it is it's magnetic induction from one circuit to the other one. It's exactly how a transformer operates from the primary to the secondary.
Yep. And can be wired for step up, for step down in a transformer.
But I mean, the proximity of the circuit makes a big difference of it. Yep. Romex, it usually carries the ground wire, but if you have 2 circuit, that's a big one. Is when you see two, just a hot and a not, hot and neutral running for a little while, and then they don't have the ground or something nearby, it can affect it too. But so the low Z is really good for that.